Hello, in today's lesson we're still studying circles, but today what we're going to focus on is the central angle inside of a circle, not the inscribed angle. Now a central angle is simply an angle that has its vertex at the center of the circle, and the other two sides of the circle end on other parts of the circle. And this one's pretty easy. The measure of the arc subtended by a central angle is the same as the central angle. So if this angle is 120, this arc is 120. Super easy. We just have to keep it straight, that it's not the half like the inscribed angle was in our previous notes. So let's take a look. Example 1, GJ is the diameter of circle K. Okay, I see that over there on the right. Identify each arc as a major arc, minor arc, or semicircle. Oh, okay, and then find its measure. Let's see, the measure of, no, they should actually put little arc symbols up above here. Let's see, the measure of GH. GH is this arc. So this arc subtends this central angle of 122. So first, this is a minor arc because it's less than half a circle, and it's 122 degrees. Next, let's go red. GLH. Now hopefully just from the three letters you can see that this is a major arc because it's more than half a circle. And I can figure this out since this angle is 122 degrees and this is basically the rest of it. It's just 360 minus 122, which is, I don't have my calculator open. All right, which is 238. All right, last one in this set. Let's go orange. GLJ. GLJ. GLJ is a half of a circle, so this is a semi-circle. And half of a circle is half of 360, which is 180. All right, adjacent arcs. The measure of an adjacent arc formed by two adjacent arcs is the sum of the measure of the two arcs. That's hopefully like common sense. This arc and this arc add up to the total of this whole arc. So if I wanted to find this angle and I was given maybe arc XY and arc YZ, I could just add the two of them together and that would be my central angle. So let's see, example 2. Find the measure of arc AED and ADB. So, first things first, AED, AED. So that's this central angle, so it looks like it's 90 and 63, which is 153 degrees. ADB, ADB, so that's all the way around here. Let's see, I don't know the measure of either of these arcs, really. But what I do know, or I'm sorry, those central angles, but here's what I do know, ADB. This is a half a circle, so that's 180, and that's 63. So 180 and 63 is what, 243? So that's one way to find it, 243 degrees. Oh boy, all right, now we're combining basically what we did with the inscribed angle and central angles. So find the measures of angle BAC, so this, and BDC, which is BDC, this. Okay, well here's what I know. I know that the measure of angle BDC is half of angle BAC, because since both of these subtend the same arc, and BAC is equal to that, and BDC is half of that, that means that BDC is half of BAC. So here's what I can do. BDC is x plus 14, and half of angle BAC is half of 7x minus 7. Now I just have to solve this equation to find x, to find the measure of my angles. So what I'm going to do is multiply both sides by 2. The reason I'm doing that is it's going to cancel out with the 1/2. It's just going to make it easier for me. So I have 2x plus 28 equals 7x minus 7. I am going to subtract 2x from both sides since my x's are on opposite sides. So I get 28 equals, what is that, 5x minus 7. Now I'm going to, what am I using here, red, add 7 to both sides. I'm going to go to the side here. So what is that, 35 equals 5x, and dividing by 5, it looks like I get x equals 7. So the measure of angle BAC, if x is 7, oh boy, look at that, 7 times 7 minus 7. What is that, 49? Oops. 49 minus 7, which is 42. So that's 42 degrees. Doesn't look like it's 42 degrees, but that's what they're saying it is. And the measure of angle BDC is x plus 14, which is 7 plus 14, which is 21 degrees. So those are the measure of my two angles. Oh boy, example 4. This one's kind of crazy. Well, since these two sides are congruent, since these chords are congruent, these arcs are congruent. Since these arcs are congruent, those angles are congruent. So since they're congruent, they're equal. So I'm going to get that. I'm going to solve this. I'm going to subtract 8y, again, because the variables are on opposite sides. So I'm doing the opposite. That's weird. Did I write something down wrong? No. So what am I going to do here? Blue, I'm going to add 48. Kind of a weird answer. So I get 5y equals 1, so y equals 1/5. We're just used to seeing kind of constants, or whole numbers, I'm sorry, that in these types of problems, but this one doesn't have that. All right, a couple more quick ones. If two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. Sorry. So basically the same thing as the previous one. Since these two angles subtend the same arc, these two angles are congruent. So I can say that 3x I'm sorry, look at it wrong. So find the measure of angle T. So I'm saying 3x minus 5 equals, I should have put a little more room in here, 2x plus 15. So subtracting 2, I get x minus 5 equals 15. Adding 5, I get 20. So the measure of angle T, is 3 times 20 minus 5. What is that? 60 minus 5, 55. Now, they're saying the measure of angle S is 3x. So they're saying this one is 3x, and angle V is x plus 16. Both of these subtend the same angle, so again, they're congruent. Oops. So I'm going to subtract x from both sides, divide by 2, and I get 8. So the measure of angle S is 3x, so it's 3 times 8, which is 24 degrees. Excuse me. And that's it. I hope that was clear. Started off pretty easy. It's just if two angles subtend the same arc, they have the same value. And then at the beginning up there, let's see, the central angle is the same as the arc it subtends. All right, hope that was clear. Have a great day.